Hello friends, welcome back to my channel. My name is Verdasir and today we are gonna study about light, the part 3. So first we are gonna talk about the formation of image by plane mirror. Okay, let's see. First, we will we'll draw a plane mirror. We will draw a plane mirror here. It's a plane mirror and here it's the object and here it's light. Not light, sorry, eye. The observer's eye. Observer's eye. The light rays are coming from an object and going to the observer's eye. Many light rays are coming from this object. Okay, and some are getting absorbed also. They will be continued here, and they will continue and meet at a point I. Here at I, the image is formed. Image is formed. When light rays from an object hit the mirror, after reflection they appear to meet at eye. Here. Image is seen at eye. Image is always formed behind the mirror. Behind the mirror. And the distance of the object, this, is always equal to this. Okay? Now let's move on. Let's see the types of images. There are two types of images, real and virtual. A real image is when the rays of light actually meet. The image so formed is known as the real image. A real image is always inverted. Real image, always inverted. And a real image can be caught on the screen, can be viewed on a screen. On a screen. And a real image is formed by a convergent reflected beam. I told you what is convergent beam. Convergent beam is when the objects, the light rays are coming and converging at a point. Okay. Now let's talk about virtual image. When the rays of light appear to meet, the image so formed is known as virtual image. The virtual image is always erect. Always erect. And a virtual image is formed by a divergent reflected beam. I told you from a point so many light rays are coming. It is called divergent beam. By divergent, remember, by divergent virtual image, I'm writing VI, and by convergent real image. Okay, now let's move on. The use of plane mirror. Let's now look at the use of plane mirror. Plane mirrors are primarily used at as looking glasses. As looking glasses. Since a combination mirror can produce multiple images, they are used to provide false dimension in showrooms. And they are also used as a reflector in solar cookers. And they are used in periscopes, kaleidoscopes, in carving mirrors, in microscopes. So there are lots of uses of plane mirrors in our daily life, you can say. Now let's look at lateral inversion. What it basically is lateral inversion. When an object is kept in front of plane mirror, the sides are reversed. Right becomes left and left becomes right. This phenomenon is known as lateral inversion. This means that when you're standing in a plane mirror, like here, the boy is standing in a plane mirror, and he is raising his right hand. When he will raise his right hand, the mirror will raise the image of his image will raise the left hand. And when you see, if you have seen an ambulance, it's always written ambulance as inverted, like as a mirror image, so that if people will see in a mirror, they can read clearly. Okay. Now let's talk about multiple reflections. Here, suppose there are two mirrors here. There are two mirrors. This is the first mirror and they're perpendicular to each other. Their second mirror. A light is coming, light rays coming and then going. And here again it's like so. If we have more than one mirror, light may undergo multiple reflections. Remember, for multiple reflection, you need to learn this definition. It's very important. Sorry. When multiple reflections happen, sorry, mm, when multiple reflections happen, the reflected ray of the previous, like this is the reflected ray for mirror 1, but it's the incident ray of the second. It's incident ray of the next. When light is incident on a plane mirror, a small part of it is absorbed, due to which reflected light has slightly less density. Like so, now we understand by this statement, like if you will draw so many mirrors here, I mean you cannot place mirror like this, like here. So when a reflected ray is going in again coming, it's slightly less intensity is have intensity. Okay. Now let's let's look at the multiple images which are formed due to multiple reflection. Multiple images are formed when two or more mirrors are there. Multiple images of an object. There is a formula to calculate the number of images, and that formula is number of images is equal to 360 over theta. Theta is the angle which is given, like where the images are placed, -1. Okay. So let's see. Suppose let's we take an example. The theta is 60 degrees. Okay. So over 60 degrees minus 1. I hope you can do this. You will cancel the zeros. 36 divided 6 minus 1. So how many images will be formed? 5 images will be formed. 5 images will be formed. Okay. Uh, this formula is so simple. Just you need to remember this. Now let's solve a question about the multiple refraction. I've not drawn the picture yet. Let's draw it. Find the angle of reflection for the second mirror. Like here's the first mirror, second mirror, it's perpendicular here. It's mirror. Remember, always to represent the mirror, you have to draw this line. And here the incident ray is coming, here the reflected ray, and here's the incident ray again. Here. So let's draw a norm. Always if you're solving a question, first you have to see what is given. It's 30 degrees. Let's draw a normal here also. You should always have, we should find this angle of reflection. This is given as C, this is given as A, and this whole is B. Now, A is equal to I, which is equal to 30 degrees. They are equal, and A plus B will be 90. So we already know the value of A. So B will be 90 minus 30, which will be equal to 60 degrees. B is equal to C by alternate angles. I hope you have already studied in maths. If like this and this angles, Z angles are always equal. So this, and so C will be 60. And as we know that they are equal, so R will also be 60. Okay, this was so easy. There are more hard numericals on this, on which in the next lecture we will talk about. Okay, let's look at the next slide. Periscope. What is periscope? It's a long tube-like device. It's a long tube-like device that is used to view objects beyond an obstacle. Like I will draw a periscope here. Periscope, sorry, this is not correct. Periscope is like this, and this. Here is the eye. Like, here is the object. I'm writing the short form. Here is the mirror, 45 degrees it's placed. Here also mirror, 45 degrees it's placed. It's coming like this. The light is coming like this. In its simplest form, it consists of an outer case which and each other. All the mirrors are at 45-degree angle and they're set parallel. Remember this, they're set parallel. Okay? I hope you understand this much. Now, you should know the R part of eyes. The sclera, it's a white part of the eye. It protects the eye and give it shape. The choroid absorbs light. The yellow spot, it's most sensitive spot. And the retina is the light sensitive inner lining. The cornea it helps in refracting light. Okay? How the eye see? How do we see? Okay, let's now look at this. If we have to see clearly, our eye must be able to focus on the light rays. Is it true or not? Yeah, okay. Onto the retina. To do this, the lens needs to change its thickness. Basically, how do we see? By changing the thickness of the eyeball, the thickness of our eyeball. It's so simple answer, and here I've given for more information. I have given this to for you for more information. Okay, how the light see, I have given more of this. Okay, so this was the end of the chapter light. In the next lecture, we will solve some numericals based on light. I hope that numericals will be easy for you because I've explained you. And if you like this video, don't forget to like, comment and subscribe my channel. And you can find the link in the description of the other videos of the same chapter. Thank you. Bye bye.